Hello friends, welcome to the e-learning program of KTHM College Nasik. I am Dr. M.K. Deore and today I am going to take the second lecture on the sixth chapter, types of the lasers. Friends, in the first lecture we have seen about the classification of the laser according to the different modes and also the types of the lasers. The first type of the laser we have seen the solid state laser, in which I discussed with you in details about the ruby laser. Friends, today I am going to take the second type of the laser, that is the gas laser, in which I am going to discuss with you in details about the helium neon laser. Friends, now I am going to take in details about the gas laser and the construction and working of a helium neon laser. In a gas laser, the laser medium is in the gaseous state, and due to that it is known as the gas laser. A gas laser is a type of the laser in which there is a mixture of the gas is used as the active medium, which is also known as the laser medium, and the mixture of the gas is packed into a glass tube. Now see here in this figure we can see here is the glass tube and the mixture of the gas is packed into this glass tube. In a gas laser, an electric current is passed through a gas inside the laser medium to produce the laser light. A gas laser is the first laser that works on the principle of converting the electrical energy into the light energy. The gas lasers are the most widely used type of the lasers as compared to the other type of the lasers. Now there are the different types of the gases are used as a active medium. Now such as the helium neon, and according to that the gaseous laser are of the different types, such as the helium neon laser, the argon ion laser, the carbon dioxide lasers, the carbon monoxide lasers, the excimer lasers, the nitrogen lasers, and the hydrogen lasers. Now that means the different types of the gases used as active medium, and according to that there are the different types of the gas lasers are available. The gas lasers are used in applications that require the laser light with a very high beam quality and the long coherence length. That means the gas lasers are used in such applications where we require the light with a very high beam quality, and second one is that the long coherence length. Now we are going to see in details about the helium neon laser. The helium neon laser was the first gas laser to be operated successfully. It was developed by the Ali Jawan and his co-workers in Bell Telephone Laboratories in 1961. The helium neon laser is one of the most widely used laser. Now then, we are going to see the construction of a helium neon laser. We have studied in details about the three main components of the laser. Similarly, the gas laser also having the three main components. The first one is the gain medium. in which a laser glass tube or the discharge glass tube is used, and inside the discharge glass tube there is the mixture of the different gases used as a active medium or the laser medium. The second element is the pump source. An electrical pumping method is used with the high voltage power supply to discharge the gas inside the glass tube. The third component is the resonating cavity. In a helium neon laser, the excitation of the electrons in the helium neon gas is achieved by passing the electric current through the gas, and so the high voltage power supply is used. Now then, the first one is the the gain medium. In a helium neon laser, it consists of a long discharge tube of the length 50 cm and the diameter of the 1 cm, and the partial pressure of the helium is 1 millibar, and whereas that of the neon is 0.1 millibar is maintained inside the glass discharge tube. Now in helium neon laser, the gain medium of the helium neon laser is made up of the mixture of 10 parts of the helium to the 1 part of the neon gas, that is the 10:1, which is contained in a glass tube at the low pressure. So remember that the ratio of the helium to a neon gas is 10:1. That is, the 10 part of the helium is used and the 1 part of the neon is used here. Now in this helium neon laser, the neon atoms are acts as the active centers and having the energy levels suitable for the laser transition, while the helium atoms help in exciting the neon atoms. So the friends, you have to be remember here, in helium neon laser, the neon atoms acts as the active centers. In helium neon laser, the electrodes of the discharge tube, such as the anodes and the cathodes, are provided in this glass tube to send the electric current through the gas mixture. Now see here, this is the glass discharge tube, in which we can see here that the two electrodes, one acts as an cathode, another acts as an anode, and these two electrodes are connected to the DC power supply. The second component is the pumping source. Now in order to produce the laser beam, it is essential to achieve the population inversion. Now in first chapter we have seen about the population inversion. The population inversion is the process of achieving the more electrons in the higher energy state as compared to the lower energy state. That means for the lasing action, the population inversion is very important, and in a helium neon laser, in order to achieve the population inversion, here we need to supply the energy to the gain medium to excite the primarily the lower energy state electrons to the electrons of the helium atoms to the higher energy state. Now in this helium neon laser, by applying the high DC voltage power supply is used here, and by applying the high voltage across these two electrodes, these DC high voltage produces the energetic electrons and that travel through the gas mixture. That means by applying the high DC voltage across these two electrodes, there is the flow of the electrons through the mixture of the helium and the neon gas. The third component is resonating cavity. In the helium neon laser, it uses a glass tube which containing a mixture of the helium and the neon gas. And this glass tube is placed between the two parallel mirrors. These two parallel mirrors are silvered or they are optically coated. In this helium neon laser, these two mirrors form the resonating cavity, which is also known as the optical resonator. Now here each mirror is silvered differently. The left side mirror is partially silvered and is known as the output coupler, whereas the right side mirror is fully silvered and is known as the reflector or the fully reflecting mirrors. That means the one mirror having the 100% reflectivity and the second mirror, that is the output mirror, having the partial reflectivity. So the pair of these two mirrors forms the resonating cavity, which is also known as the optical resonator also. The fully silvered mirror will have the 100% reflectivity and it completely reflects the light, whereas the partially silvered mirror will reflect most part of the light but allows to some part of the light to produce the laser beam. That means due to the partial reflectivity, it also allowed some part of the light to produce the laser beam. Now that we are going to see the working of the helium neon laser. Now in construction we have seen that the glass discharge tube consists of the two electrodes and the very high voltage power supply is connected to these two electrodes. And when the power is switched on, the high voltage about the 10 kilovolt is applied across the gas mixture, and this power is enough to ionize the gas and excite the electrons in the gas mixture. Now that means see, now we can see here, this is the glass discharge tube and the high voltage power supply is get applied here. The high voltage DC power supply is nearly about the 10 kilovolt. Due to this high voltage DC power supply, the electron produced in the process of the discharge and they get accelerated between these two electrodes, cathode and the anode, through the gas mixture. So now in this way or in this process, there is the flowing, these electrons are flowing through the gas and these energetic electrons transfer the sum of their energy to the helium atoms in the gas. So now see here, these are the high speed energetic electrons we can see in this figure here. These high speed energetic electrons, when they collide with the helium atoms, then they transfer there is some part of the energy to the helium atoms which are in the ground state level or the lower energy state level. Now, as a result, the lower energy state electrons of the helium atoms gain the enough energy and jump to the excited state. So now see here in this energy level diagram, we can see here that when the helium atoms receive the some energy, now then these helium atoms gain the enough energy and they jump to the excited energy levels. Now we can see here the excited energy levels in case of the helium atoms, say as the F2 and the F3. Now these excited energy levels in the helium atoms F2 and F3 are also known as the metastable state. Hence, when the excited electrons of the helium atoms collides with the lower energy state electrons of the neon atoms, then they transfer their energy to the neon atoms. After that, the atoms which are the helium atoms which are in the metastable state, they collide with the neon atoms which are in the ground state energy and they transfer. Now see here, the atoms which are in the helium atoms which are in this metastable state collides with the neon atoms which are in the ground state and they transfer their energy to these neon atoms. As a result, the lower energy state electrons of the neon atoms gain the enough energy from the helium atoms and jump into the higher energy states which are also known as the metastable state, that is the E4 and the E6. Now see here, in this figure we can see that the neon atoms which are in the ground state gain the sufficient energy after colliding with the helium atoms, goes to the excited energy state E4 and the E6. These E4 and the E6 are also known as the metastable state. In the neon energy level diagram. Now thus the helium atoms helps the neon atoms in achieving the population inversion. So here the helium atoms transfer their energy to the neon atoms. So we can say that the helium atoms help the neon atoms in achieving the population inversion. So now in this figure we can see here this E6 and the E4 are considered as a metastable state. Now thus, the millions of the ground state electrons of the neon atoms goes to the metastable state. We know that the metastable state have the longer lifetime and due to that the population inversion achieved there. Therefore, a large number of the electrons will be remains in the metastable state and hence the population inversion will be achieved there. Now here the energy level of the sum of the excited state of the neon atoms are identical to the energy level of the metastable state of the helium atoms. Now that means in this energy level diagrams we can see here the energy level of some of the excited state of the neon atoms are identical to the energy level of the metastable state of the helium atoms. That means which states of the helium and the neon state are identical, now we can see. Now let us assume that the identical energy states of the helium and the neon, that is the F3 and E6. That means here this is F3 and the E6. These two energy states are the identical. Similarly, the F2 and the E4 are also the identical state. Now here we have considered already that the E4 and the E6 are acts as a metastable states in case of the neon atoms. Now after the some period, the metastable state electrons E4 and the E6 of the neon atoms will spontaneously fall into the next lower energy state, that is the E3 and the E5, by releasing the photons of the red light. And this is known as the spontaneous emission. And thus the lasing takes place and the light will be produced corresponding to the transition. That means after the some period, there will be the transition from the two metastable state E6 and the E4 to the lower energy state E5 and the E3. That means there is the transition of the neon atoms from the metastable state E6 to the E5 and E6 to the E3. So now in this diagram we can see that there is the transition from the metastable state E6 to the lower energy level E5 and the E3. Similarly, the another metastable state E4, there is also the transition to the lower energy state, that is the transition of the neon atoms from E4 to the E3. So we can see here. Now thus during this transition, there is some radiation of the light, and corresponding to this transition we can see here. During the transition from the E6 to the E5, this transition generates the laser beam of the red color having the wavelength the 3390 angstrom unit. Similarly, in case of the transition from E6 to the energy level E3, there is the transition which generates the IR beam, that is the IR radiation of the wavelength 6328 angstrom unit. And from the energy level E4 to the E3, there is also the transition which generates a light of the IR region having the wavelength 1105 angstrom unit. Now that means we can observe here in these three transition from E6 to the E4, these are the radiative transition, and in this radiative transition, the three types of the radiations we can observe it. That means that from E6 to the E5, the red color, it generates the beam of the red color having the wavelength 3390 angstrom unit. Now then from the E6 to the E3, it generates the IR beam of the radiation having the wavelength 6328 angstrom unit, and from E4 to the E3 there is the transition which generates the beam of the light which is in the IR region having the wavelength 1105 angstrom unit. So the friends, you have to remember here which energy levels in a neon atom acts as a metastable state, where the population inversion arises, and how much radiations will be generated during these three type of the transitions. Now thus the neon atoms in the terminal laser level, that is now here the E3 acts as the terminal level, and in these neon atoms the terminal laser level E3 decay very rapidly to the E2, and but here the E2 is not a ground state, and the transition from E3 to the E2 level gives rise to a familiar orange color of the neon light. So in case of that, the fourth transition from the energy level E3 to the E2, during this transition there is also a emission of the light, and it gives a familiar orange color of the neon light having the wavelength 6000 angstrom unit. Now in this energy level diagram, now again here the E2 is acts as a metastable state, and during the transition from E2 to the E1, in this transition can be produced by the collision with the walls of the discharge. Now that means what will happen here? When the electron goes from, when the neon atoms goes from the metastable state E2 to the E1, during this transition, these atoms collides with the walls of the discharge tubes, and the neon excited electrons continue on to the ground state through the radiative and the non-radiative transition. And during this transition E2 to the E1, it is a non-radiative transition. Thus, in this energy level diagram, we can see that when the neon atoms goes from the higher energy state to the lower energy state, that is the ground state energy level, that times we observe some radiative and the non-radiative transition. And in this process, the output of the laser will be in the form of the continuous wave. Now in case of that the ruby laser, we have seen that the output of the ruby laser is in the pulsating mode, but in this case here the output of the helium neon laser is in the continuous wave mode. Now here the photons emitted from the neon atoms will move back and forth between the two mirrors until it stimulates the other excited electrons of the neon atoms and causes them to emit the light. Thus, the optical gain is achieved, and this process of the photon emission is called the stimulated emission of the radiation. In case of the helium neon laser, due to the optical resonator, in between these two pair of the mirrors, now there is the reflection of the light, and which moves back and forth between these two mirrors until it stimulates the other excited electrons of the neon atoms, and these neon atoms and which produces the photons which are moving along the same directions and which are in the same phase, and thus the optical gain is achieved, and such a process of the photon emission is called the stimulated emission of the radiation. Thus the light or the photons emitted due to the stimulated emission will escape through the partially reflecting mirrors, that is the output coupler which produces the laser light. So the friends, in the working of the helium neon laser, you have to be remember the energy level diagrams. The energy level diagrams of the helium neon laser, the helium neon laser consists of the two parts. One part is the energy level diagram of the helium and second is the energy level diagram of the neon atoms. So you have to be remember here that the helium atoms transfer the energy to the neon atoms, and the neon atoms goes to the excited state, and after that there is the transition from the metastable state to the ground level. We observe the radiative and the non-radiative type of the transition. So remember here which are the different types of the transitions occur in the different during the different transitions, and what type of the radiations having or how much what type of the wavelengths will be emitted during this transition. Now then we are going to see the advantages of the helium neon laser. The helium neon laser emits the laser light in the visible portion of the spectrum. That means we have seen that the during the different transition of the helium neon laser, we observe that the red light, the orange light, and the IR radiations also. The second one is the it having the high stability. The helium neon laser, which having the low cost and also operates without the damage at the higher temperatures. Simultaneously, there are some disadvantages of the helium neon laser, such as the low efficiency and the low gain. So remember here, the helium neon laser having the disadvantages that it having the low efficiency, and second one is that it having the low gain. Nowadays, mostly the helium neon lasers are useful. Now then, see here what are the different applications of the helium neon laser. The helium neon lasers are used in industries also. The helium neon lasers are used in the scientific instruments also. The helium neon lasers are used in the college laboratories as a monochromatic source. Now, number of times you have used the monochromatic source in the laboratory to do the laser experiments, and in that case we are using the helium neon laser. The helium neon lasers are also used in the interferometry also. Now, the experiments such as the Michelson's interferometer, in which we are using the helium neon laser. The helium neon lasers are also used in the laser printing. The helium neon lasers are used in the barcode reading. Now we know that nowadays the barcode is while purchasing the any items, the barcode is very important, and in advanced technology, the helium neon lasers are used in barcode reading also. Now, helium neon lasers are also used in the medical applications such as the eye surgery. The helium neon laser is also used in the holography also. So remember here, the helium neon lasers having the number of applications in different fields, and so the helium neon lasers nowadays are very popular. Now see here, this is the helium neon laser. It consists of the glass tube in which the mixture of the gases is packed or inserted here. By applying the high voltage, the discharge will be start there, and so it produces the beam of the laser light. Now friends, in these lectures I have discussed with you about what do you mean by the gas laser, and one of the type of the gas laser is the helium neon laser. I told you in details about its construction, its working with the help of the energy level diagram. Now the advantages and the disadvantages of the helium neon laser, and also the different applications of the helium neon laser. So friends, remember all things I have the all things related with the gas laser and the helium neon laser. Thank you.